So what is OOPS we have to see now. Okay, so before starting the OOPS, I'll just give an introduction to what C language was initially. Like if I write a small program in C language, I'm writing void main int a. Int means integer which stores integer values only, and here a equals to 10, b, or you can say a equals to 50 and a equals to 30. Printf is a function which prints the value,
Yeah.
so I just want to print the value here,
Okay.
and now 3 times I'm trying to print the value.
Yeah.
Now tell me what will be the output 3 times?
30.
Here 30, like 30, 30 and 30.
30. Yes,
So
sir.
why we got 30 means int means 2 bytes. In Windows operating system it occupies 2 bytes of memory,
Yeah.
and here if you have this a which stores first 10 value, then 50 is trying to insert it in this particular a, then 50 will be stored. So next, if you have 30 stored in a, 30 will override 50 and 30 will be stored. So here 3 times 30, 30, 30 value is getting printed. What do you understand by that? Single variable can store only one value. It cannot store multiple values. To overcome this drawback, they introduced a concept known as arrays in C language. Means if I want to store multiple values, then I have to use a concept known as arrays, where int a of 3 means 10, 50, 30. Like 3 means 3 locations, and these 3 values can be stored in a single variable or represented by a single variable, you can say, like 10, 50, 30 stored in a single variable known as a, and here on a condition these 3 values are getting stored. The condition is nothing but 10 is integer, and 50 is integer, 30 is also integer itself, right? So 3 values must be of integer type itself, and that is the condition. Means you can store n number of values in a single variable, but on a condition that it can store only same data type. Means there is a drawback in arrays concept. What's the drawback? You can say it can store only same data type itself. It cannot store different data types. So in order to store the different data types, we are using a concept known as structures. To store different data types, we are using a concept known as structure. Like struct is a keyword which is used to declare the structure variables, and student is a structure name, and this block is ending with a semicolon to indicate it's a separate block, and we have the variables declared inside the structure. So there's a difference between the declaration of void main and in the structure block. If I say int a is given here and int id is declared here, int a allocated memory means 2 bytes of memory is allocated directly to the a variable here. There is no restriction. And inside the structure block for int id, there is no memory getting allocated. Means for the structure block, how many variables we declare, for all the variables there is no memory allocated. So int does not occupy 2 bytes, float does not occupy 4 bytes. So there is no space available for the structure block, and without the space you can't store any value. So we need to allocate the memory for the student, right? So how we can do that? By creating a term known as object. Means here we have to create a term known as object by using the syntax structure name, then the particular struct keyword also should be used, and along with that structure name we can give that particular object name also. So what is Rahul here? An object. Okay, so here Rahul indicates a memory block for the entire structure. Like for int it occupies 2 bytes, and for the float it occupies 4 bytes. Total 6 bytes of memory is indicated by Rahul. Like here in RAM we have a memory block. Inside that memory block we have an ID and we have a percentage. And here this ID has 2 bytes and percentage has 4 bytes. This entire thing is represented by Rahul with a particular memory of 6 bytes. So totally 6 bytes are there for Rahul. Now I want to see the memory. I'm saying that ID is having 2, I'm saying that Rahul is having 6 bytes. Means in Rahul memory only we have ID, in Rahul memory only we have percentage. And I said that for direct ID there is no memory, for direct percentage there is no memory, right? So in order to see that, we have a operator known as size of in C language. Okay, so I just opened a compiler in online where I'm writing a struct student, and in this student we have ID and percentage. Along with that a main is there where I have written a printf the size of A. So I have to declare the A variable, right? So I'll declare the A variable here. So if I compile and execute this, I got the size of as 4, right? So that size of is nothing but 4, you can see. But suppose if I try to see this particular printf where ID has been given, means if I compile now you will get error saying that ID that doesn't have any particular ID, like ID cannot be understood. Okay, so why it's happening? Because there is no memory for ID inside the structure block. For percentage also there is no memory. If I write instead of ID percentage, then also we'll get the same error.
Same
To
thing. Okay.
allocate the memory we need to create a term known as object. For the syntax struct student, Rahul is a memory block and Rahul contains 6 bytes of memory. So if you want to see that directly, I am writing instead of A Rahul. Okay, so
Okay.
if I
Okay.
compile and run, I'll get some like here it's a Linux terminal, that's the reason I'm getting 8. But if you have a Windows terminal, then you will get this particular thing as 6. Okay,
Okay.
because in Linux we'll have 4 bytes of memory for integer.
Okay.
Now if I want to see how much memory is there for ID, then how to specify means we have a particular dot operator which is used to access the structure variables. So from this block if you want to access, you need to have the memory. This is the memory,
Yeah.
and based on the memory if you give the variable name, then you can access directly. Like if I compile now and if I execute again, so we got this 4 bytes, right?
Yeah.
Size of is 4. And
Yeah.
if you see, if I compile it with Rahul dot percentage, then again this particular output will be size of will be 4 and 4. So
Yeah.
4 for ID and 4 for
4 for.
percentage.
Yes.
Okay, so this entire memory is nothing but 8 bytes in Linux terminal and 6 bytes in Windows terminal, because integer varies from uh, operating system to operating system. Okay.
Yes.
Now if I create one more object like Kiran, so what will happen here? Another memory block will be getting created, right? So if I say Rahul and Kiran are there, I can access both the times like rahul.id, kiran.id, right? So
Yes. Yes.
if I write the same program without creating object or without the structure, I'll write the entire program without structure now. In a single variable, we can store only one value. So two students are there means ID1 to ID2. Two variables are required for Rahul as well as Kiran, you can say, right?
Okay. Yes. Yes.
Now, if I have 60 variables, then 60 students are there, so 60 variables will be declared, right?
Yeah.
Or else you can declare it as array, like idea of 60. But array drawback is same data type, and we cannot store different data types. And if I have declared idea of 60 and only 10 students came, so 50 blocks are wasted, right?
Yeah.
So the memory cannot be increased or decreased dynamically for an array. To
Okay.
overcome these drawbacks, we are using a concept known as
Structure.
structures. Okay,
Yeah.
so here in these structures, the ID variable has been declared only once, and I was able to use it twice based on two objects known as Rahul and Kiran. Means variable can be declared only once, can be used multiple number of times based on the memory blocks known as Rahul and Kiran. Now, what is a like extension of structure? How can we still extend the structure means? Here, if I writing a function, one function for one student, then two functions for two students, 10 functions for 10 students, and 60 functions for 60 students will be required. So, the prolonging the program, okay? Here, if you write the function inside a structure, then it can be written only once. We can access it n number of times based on m number of objects. But according to the definition of structure, structure can have only data types. We cannot store any functions inside the structure. Means we can't write function inside a structure block. It is a collection of different data type itself. So to extend the structure concept, they introduced a concept known as class in C++, where I can write both variables as well as you can say functions, which is not done inside the structure. Okay, and this is a concept known as class. It's a collection of variables as well as functions, you can say. Okay, we should know what is OOPS concept, because C++ follows OOPS, Java follows OOPS, and a lot of languages are there which follows OOPS, right? So
Yes. Sir.
OOPS is nothing but object